All right, let's fill in some of this stuff here. Some of you may have known, some of you may not have. Let's look at the chart first. Okay, so we're going to go through what each one would be called. Number of sides, I hope 3. You did know that one. Triangle is correct. 4 sides is a quadrilateral. 5 is a pentagon. So you got triangle, quadrilateral, pentagon. 6 sides is a hexagon. 7 is a heptagon, H-E-P-T. 8 sides, octagon. That's usually one we do remember. 9 sides is a nonagon. 10 sides, close, decagon. Remember, yeah, 12 is dodecagon, but 10 is decagon, just like a decade's 10 years. Decagon is 10 sides, and then 12 is dodecagon. Decagon with a do in front of it. Now the last one for the n-gon, you just put n dash gon. Okay, on number 2, okay, you guys see if you look at 2A, every one of those shapes has 2 sides that go together and point inward. Whereas if you look at 2B, none of those sides have 2 sides that point inward, do they? Okay, so on 2A, those are going to be concave. If you're trying to remember that, don't overthink it. Just think like cave in. So they're concave. There's 2 sides that point inward. Convex is the other one. That is when they all point out. So 2A is concave, 2B is convex. On 3 and 4, we're going to use the word equal, E-Q-U-I. On the first one, equilateral means all the sides are the same. On number 4, equiangular is all the angles are the same. Has anybody missed anything so far? We're good? Okay, number 5. Now this will be important. So circle number 5. All of it's kind of important, but we use this word a lot. The word regular. Number 5 is regular. And what number 5 is doing is combining 3 and 4. So 3 was equilateral, 4 was equiangular. When both of those things are true, they call the shape regular. So regular polygons are equilateral and equiangular. It means sides are equal and angles are equal. All right, and you can circle those if you want to. That's not a big deal. Okay, go down to where it says polygon angle sum. So this is the thing where this is the main part of the lesson. Okay, so what we're going to do today is we're going to figure out what the angles inside shapes add up to. Okay, so when they use this word polygon, okay, we didn't talk about that at first, but polygon is a general word for all of these shapes. Okay, any side, any number of sides. Okay, then the next word is angle. So we're talking about all of the inside angles on these shapes. And then what does the word sum mean? It means you're adding them up. So what we're going to do today is talk about how can we figure out what all of the angles inside a shape add up to. Okay. Now one of them we already know. What do all 3 angles in a triangle add up to? 180. We're going to use that to figure out all of the rest of them. Okay. So the very first thing I want you guys to do, if you go down to the shapes where it has the triangle and then there's a, you guys see the quadrilateral? Okay, so starting right here, we're going to connect the other vertex like that. Now the pattern is this. If I started there, that's the only one I can connect. You guys agree with that? Like I can't go there because that's already a side. I can't go there. So how many triangles did it form? There's two there, isn't there? Okay. Now let's go over to the next one, which is a pentagon. Okay. We're going to pick this one here to start with. It really doesn't matter which one you start with, but if we all do it the same, it'll probably help us a little bit see it better. So if we start there, you guys agree I could connect to there? Okay. There's one I could connect. And then there's actually one more I could connect this time, isn't there?
Can't we still make another triangle at the top point, not to where you started, but top and then right down to the bottom?
Well, you got to always go from the same vertex, okay? Because what we want is when we do this pattern, we're starting from the same vertex because basically all of the triangles that we make would make up the big shape. So we don't want, you're not just drawing in as many triangles as possible, okay? It's only so it would make just that exact shape. So in this case, when I start here, okay, and I connect there, how many triangles have we made? There's three, right? You guys with me so far? Okay, let's go to the hexagon. Now, once again, you don't have to start at the same, this one vertex I'm at, but you have to do this same pattern from whatever vertex you start at. So if I start here, I draw across, I can connect there, I could connect there, and I could connect there, right? Okay, so this time, when I do all those connections, you guys see how I made 1, 2, 3, 4 triangles? Okay, you guys do the next one, the octagon. I'm sorry, actually the next two, the heptagon and the octagon. Connect those. Okay, and what I'm hoping you see once you connect those on the heptagon, you guys see you have 5 triangles. On the octagon, how many triangles do you have? There's 6. There's how many? There should be 6. Okay, so what we're going to do now is we're going to figure out what this pattern would be. All right, so on that chart down there, they've got this part filled in for you. Okay, a triangle has 3 sides. So obviously there is one triangle in a triangle. Now we're not going to overthink this, but they put this as gray, but what they're basically saying is if I do 1 times 180, I get 180. Is everybody good on that? Okay. Now the next shape we did was this quadrilateral. So what we're going to do is, think about this for a second. In this quadrilateral, I got 4 angles, don't I? Okay. It's this angle, those two together, that one, and those two together. Do you guys agree that that would be what these 2 angles together would add up to? What I mean by that is the angles. If I got 180 here and 180 there, that would add up to 360, wouldn't it? Okay, now here's how we're going to write that out. So first, it's got 4 sides. Let's put that down. Quadrilateral has 4 sides. How many triangles did we say was in that quadrilateral? 2. So if we do 2 times 180, that means that in a quadrilateral, all 4 angles add up to 360 degrees. Okay, in the pentagon, how many triangles do we have? 3. I should have said this first. In the pentagon, there's 5 sides, right? I'm going to write that down first. Now we said there was 3 triangles, correct? So this time to figure out what the pentagon angles would add up to, if I take 3 times 180, it 540. Okay, this would be 540 degrees. Hexagon has 6 sides. How many triangles we say were in the hexagon? 4. So we would take 4 times 180. So we would get 720 degrees. All right. So this next thing we're going to write down is basically the polygon angle sum. Okay, so you guys tell me, what's the pattern? If you know the number of sides, do you know the number of triangles? What is it always going to be less than? Or how much less is it going to be? 2 every time. So if we have, this is going to be the formula part, the polygon angle sum. So we're saying if I have n sides, so this would be for any shape, the number of triangles would be n minus 2. Does everybody see where I'm getting the n minus 2 from?
How do you know if it's a non-God, in-God?
With n stands for we don't know how many sides it has, so this would be for everything. So basically what we're saying is we want to come up with basically a little formula, the polygon angle sum formula. So that if we know it had 12 sides, could we figure out what all the angles add up to? Okay, that's what we're doing. So n stands for a number,
So
whatever it would be.